Okay, so last video, very briefly, here I have two different trinomials. I would like you to try to factor them both, but try to pick out which one is the difference of squares first, and that will make it really easy for you to factor that one, hopefully. Okay, so pause the video, and I'm going to show you the answer in about 3 or 4 seconds. Did I say difference of squares? I think I did. I meant to say which one's a perfect square. Maybe I got it wrong. Who knows? Anyways, obviously the one on the left is the perfect square. The square root of the first term is 2x. Square root of the last term is 3. 2x times 3 is 6x. 6x times 2 is 12x. Now it's negative. That may have thrown you off, but if I made this a negative 3, negative 3 times negative 3 is positive 9. And then 2x times negative 3 is negative 6x. Negative 6x times 2 is negative 12x. This does work out to just be 2x minus 3 times 2x minus 3, or 2x minus 3 squared. The one on the right is a perfect square, it looks like, because the square root of 9a squared is 3a. The square root of 1 is 1. And so if this was a perfect square, we'd go 3a times 1 is 3a, times 2 is 6a. So if this said 6a, that would be a perfect square, but it doesn't. So it's not a perfect square. I can't factor it like that. That doesn't mean it's not factorable, because 10a is the same thing as saying 9a squared plus 9a plus a plus 1. In other words, I'm doing the magic number method. It still works. It still can be factored. It's just not a perfect square. So always check to see, first of all, if you can pull out a GCF, and if you can, do that first, and then check to see if it's a perfect square or if it's a difference of squares, and then factor them easily that way. And if that can happen, but they can still be factored, go ahead and do that. So you're not just looking for one way, you're looking for like 3 or 4 different ways you can factor something. And by the way, if you carry this one out to completion, this is what you get for the answer. A plus 1 times 9a plus 1. Again, factorable, but just not a perfect square. Okay? So, there you go. That's all we're going to do for right now. And tomorrow in class, we'll try a few more examples and have a whole bunch of homework. Oh, it'll be so exciting. We'll see you then.